on my desk.
No. All right. Okay. All right. First, let's discuss. So the problem I want to cover today is just like yesterday's homework. We're doing a parabola, which in this case, I picked one this morning that had 3 numbers in case your problem had 3 numbers in it. The examples I did yesterday, I didn't realize. I looked back after we were all done yesterday, and I only picked examples of parabolas that only had 2 variables. You know, they didn't have that 3rd number. I made up one that has a 3rd number in it. It's the same thing. You're doing the same math. And then my line is going to be negative x plus 3. Okay, so we're going to do the same stuff. I just want to refresh your memory. Now, the only difference we're going to do here is I want to do one extra thing on this. I'm not going to require this on the homework. I just want to show you something that somebody brought up yesterday that I just thought was a really interesting problem. And I just want to show you the concept of it. So it's not something I want to do in the homework or assign. It would be more of like a calc level problem. I really liked it, so I'm going to talk about it today. Let's talk about the homework that you had. This is a parabola. It's hitting -1 on the the y-axis. If I factored it apart, if it was factorable, this is basically what the parabola looks like. It's hitting -1. So it's kind of looking something like this. I know the tails go up. They're going the same direction. They're positive, so they're going up. My linear function is starting at +3. And it's going down 1 over 1, down 1 over 1, so it's kind of looking like this. So do you agree that it's hitting in 2 locations?
Yes, sir. Yeah.
That's what we're doing. Like, that was the point of the homework. Where does the line hit the curve twice? That's what I want you to submit on the Google form. Give me the coordinates right where they hit. That's what I'm going to do right now. I'm going to refresh your memory on how to do it, especially if you were gone and you did not see these notes yesterday. I think we talked about this stuff last week even. But let's go through the math here one more time. So here's what you do. If I want to know right where these 2 items cross, where they equal each other, you set the 2 formulas equal. Okay, you just set them equal to each other right off the bat. So I'm going to take the x squared minus 4x minus 1 and immediately set it equal to the negative x plus 3. Okay? Okay, because I want to know where they equal each other. Right? Now, when we do this, we're going to complete the square. We're going to have to move things around. And what we're finding is the x locations, the coordinates, where they actually meet. And I'm going to be given the x numbers where they're meeting. Because the y numbers are already equal to each other. Okay, so how do you do this? How do you complete the square? Anything that's a normal number moves. Anything that's a variable goes to the left. So this -1 I should say, goes to the right. This negative x comes over. What happens when I move them? They switch signs. They become positive, right? So when I bring the x across, that becomes a +1x. +1x plus a -4x ends up being a -3x. Because I would add the 1 over to the -4. When I add this -1 over and it becomes a +1, it becomes a 4 over here. Because 3 plus 1. Makes sense what I just did there? Move around, add it. Okay, or change the sign, whatever you want to call it. Now, the good news on this problem is I don't have a leading number. I know I did an example yesterday where I had a leading number out front, like a 2 or a 5 or whatever it is. If there is a number out front, this is the moment right now where you'd factor it off. You divide, the 5 out or the 2 out, whatever number's out front. If it's a -1, fine, divide it out. And so you divide both of these by that number. You'd pull it out. So if this turns out to be a decimal, I know we did one yesterday that was a decimal. We did a decimal, it's fine. 2 decimal places on everything, 2. Okay, in my case, I don't have to do anything. Perfect, great. Now, I have to do half the middle squared. So, half the middle in this case, half of it is 1.5. I'm going to square it, and that turns out to be 2.25. That's half the middle squared, 1.5 squared. And that's the number I'm adding to both sides. Now, the reason why I'm going to automatically add the 2.25 across, there is no number out front that I have to deal with. If there was a number up front, you have to take that number times the number up front. And then that's what you add to the other side. And it's always positive because I'm going to be squaring it. And there's no number up front that made it negative. So what we have here is at this moment, I'm at this part where it ends up being half the middle. So 1.5 squared, that's always half the middle. Negative 1.5, I should say. And on the other side, I have 6.25. Okay, so we're here. Now, how do I solve for x? What do we talk about? Square root, right? You take the square root to the other side, you solve it. If there was a number out front, like the number we factored out earlier, if there was a number that we factored out, you have to divide that number over first, then do the square root. Well, I don't have to worry about that. I'm just going to take the square root to the other side. So I have x minus 1.5. I'm going to take the square root over right away. And I think if I square root 6.25, it ends up being like 2.5 like perfectly, which is kind of a weird number. So this ends up being 2.5 over here, like a nice clean 2.5. There's no other decimal on it. And now I'm going to move the 1.5 over to join it. When I move the 1.5 over, it becomes positive, yeah. So here's what I have for my x's. My x's turns out to be a positive 1.5 plus or minus 2.5. That's what happens when I move the 1.5 over. So these are my two x's, the coordinates where they cross. That is the whole point of your homework assignment today, right? So if I add these two together, that'll be one of my x's. And if I subtract them, that'll be my other x. So 1.5 plus 2.5 ends up being a 4. And if I take 1.5 and subtract 2.5, I get a negative 1. And again, those are my x's. Again, this x ended up being the 4. This x ended up being the negative 1. There's negative 1 over and 4 over this way. There you go. Okay, makes sense so far? Okay. And now, how do I find the y numbers?
Plug it in.
Plug it in. And I would always plug it in to the linear equation. This one. It actually doesn't matter which one. I always pick the easier looking one, and I'm plugging those x's one at a time in here. So my linear equation is this one. So I'm going to plug those numbers in kind of one at a time. So if I plug in the 4 here, so negative 4 plus 3, because 4 with a negative sign out front, that ends up being a negative 1, fine and dandy. So that number is this number right here, so it was 1 down. Didn't quite look like it, but again, I was freehand drawing that. Then if I plugged in the negative 1, what happens to a negative 1? Turns positive, and 3 plus 1, which ends up being a 4. So this is a 4 up here. So it actually ended up being really clean numbers for being something I made up on the spot earlier today. And that's the point. What you're going to type into Google Form today is this. This is what I want to see. I want to see the coordinates where they crossed. Those. I know that there's a lot of work to be had. I want to see the coordinates. I would save your work, save your paper in your notebook. Don't just tear it out and throw it away. Save it because, if you make mistakes, you can always go back and fix it and stuff. I know that some people are going to go on not Wolfram Alpha, but Desmos and type it in like, I got my coordinates. I wouldn't do that because if you're rounding everything to 2 decimal places, you will be off by the time you get to the Desmos answer because you're rounding everything to 2 decimal places. Especially if you have fractions, change them to decimals, 2 decimal places, all that good stuff. Unless there's no 2 decimals, you don't need to worry about it. Okay, questions? Okay, now, I did warn you that there is something else I want to talk about today. I just want to talk about it for 2 minutes. And this is what you're doing in your homework. That's it. That's all you're doing. The thing that somebody brought up the other day, I don't know if it was first period or if it was your guys' period, somebody brought up, it was an interesting question. It was lines crossing lines, right? So we had a curve and we had a line crossing. But the thing I thought about is like, well, we could go one step further and I could ask, where does this line cross the Directrix line at the bottom, right? Because that's what we did in the last chapter. Last chapter test, we talked about, okay, there is a focus point and there is a Directrix that goes down below it. These would actually cross like over here somewhere, this Directrix line and that linear equation. And so how you'd actually do that is you have to find the equation for the Directrix by doing the normal formula stuff that we did in the last chapter test. For this thing, find the normal Directrix, and then you set it equal to this linear equation like we're doing here, where you just set them equal. And then you solve for the variables, because it's going to cross once. These will cross down here, and I'll hit at a perfect number. In fact, that's actually what I want to talk about. So you don't need to do this, you can just watch for a few seconds. So that original parabola was this thing. So if I complete the square on this thing, half the middle is squared, half the middle is 2 squared, it's 4, add it to both sides. This ends up being y plus 5, x minus 2 squared. So the vertex on my original parabola over there, the original vertex was 2 comma negative 5. That was the original vertex on this problem over here. That was the lowest point. It was 2 over 5 down. The distance to the focus and directrix is that 1 over 4c number, and it's always 1 over 4c set equal to the number out front. 1 over 4c set equal to the number 1, because that's the number in front of my parenthesis. I didn't have to factor any number out. I would multiply the c across, divide by the 1, so my c is a 1/4. So if I went down 1/4 from this dot, my directrix would hit 5 1/4 down, negative 5 1/4. That'd be the number I'd hit. And so directrixes are written like this. That's the equation of that directrix. The focus would be 1/4 up. So the focus coordinate on this one would be 1/4 up, so it'd be negative 4 3/4. That'd be the coordinate for the focus. But the directrix is what I want. I want to know where does that line cross that one. And so you just set them equal to each other. So where's my towels at? So if I set this linear equation, if I set this thing equal to the directrix, like set those equal, I can actually figure out where they actually crossed. So you just set it equal, 5 1/4, set that equal to the negative x plus 3. You just set them equal because the y's are the same. It's just like we did with the parabola line. You just set them equal. Is this the directrix line? That's the normal like linear equation. Subtract the 3 across, you get negative 8 1/4. Divide both sides by negative 1, so that's positive 8 1/4. So that would be my coordinate where they cross. Where the directrix actually crosses. It's like over here, 8 1/4 over. And how far down is it? 5 1/4. That's how far the directrix is down. So negative 5 1/4. So that was just something somebody brought it up the other day, and I thought it was an interesting question. You can actually find where they meet. Another type of calc question is like, what is the distance between the focus and that linear equation? They can find the distance here. You know, the spot right above it to there. You can find distances. Those are like weird things that calc could calculate. So, but again, I pulled this problem up on Desmos just to show you the answers we're coming up with. So we got what, negative 8 1/4, or sorry, 8 1/4 and negative 5 1/4. So I'm going to pull this problem up again. You don't have to do any of that in the homework, or I will never assign those types of questions to you. It was just something that somebody brought up the other day, and I was like, that's exactly what we're doing right now anyway. But here you go. Here's the exact thing we're doing. Here's my parabola. There's the line. I clicked earlier on the left dot up here to show it was at negative 1 over 4 up in the air. So you can see it. There it is. And then I clicked on the right spot, and it was 4 over negative 1 down. So again, that was on the original graph. That was these 2 dots I clicked on. And then the next thing I clicked on was the focus and directrix. So you can see that was the coordinate for the focus, and I have that written over there. And then the spot where the directrix and that line met was right there, and that was the number we just came up with. So negative 5 1/2. So, or 5 1/4, I should say, not 5 1/2. But there you go. So kind of an interesting problem. I just thought that was kind of a cool problem to kind of look at. So, all right, homework. You have homework due tonight, right? Now, if you're gone, you have an exception, but for those who have been here, get it done. 5 questions, they're random. Just don't rely on your neighbor, because you are getting a random problem. I think out of the group in here, I think 2 people had the same questions yesterday. So be careful. There's usually a pair or so. All right. Remember, you're submitting on Google form. You're just submitting the coordinates. This is all I need to see. keep your work in your notebook in case you make a colossal mistake. Okay? So that's it for today. That's all we're doing.
Would there have been a